Okay, we're going to be doing arithmetic and geometric sequences. And a sequence is basically just a list of numbers. Um, and they can have patterns to that list of how you get to the next term. To determine if it's an arithmetic sequence, an arithmetic sequence is a list of numbers where there is a common difference between each term. Or basically, you're adding the same number every time to get to the next term. And whatever number that is that you're adding is called the common difference. Okay? Okay, so for these, we're going to determine if the sequence is arithmetic or not. So to get from -3 to -8, what I'm adding is -5. And then to get from -3 to -13, I'm adding another -5. But to get from -13 to -23 is a -10. So this is not an arithmetic sequence. For this next one, to get from -8 to -2, I'm going to add a +6. To get from -2 to +4, I'm adding a +6 and adding a +6. So because I'm adding a +6 every time to get the next term, this is an arithmetic sequence. I know you're used to saying arithmetic for this word. You will more than likely hear it as arithmetic when it's being referred to as a sequence or series, which is what we're doing here. And you will also need to find the common difference, which we're going to label as D. The common difference here is that common difference between each term, which is 6. A way to figure out the common difference, if you know it's an arithmetic sequence, is take a certain term and subtract the previous term. So if I take -2 and subtract the previous term of -8, well, minus the negative becomes plus a positive, and that becomes 6. That is my common difference. And so a geometric sequence is when you're multiplying by the same number every time to get the next term. And that number that you multiply by is called the common ratio, which we're going to use as R. And so to determine whether each sequence is geometric, well, in this one, just like in arithmetic, you can take a term and subtract the previous one. To find the common ratio here, you can take a certain term and divide by the previous one. So if I do 20 divided by 8, that's going to give me my ratio between 8 and 20. And that reduces to 5/2. And if I do 50 divided by 20, now I'm taking the third term and dividing it by the second term, that reduces to 5/2. And if I take 125 divided by 50, what goes into 125 is 25, and it goes in 5 times, divided by goes into 50 twice. So the common ratio every time is 5/2. So this is a geometric sequence, and the common ratio is equal to that 5/. This one, to tell if it's a geometric sequence, I would want to do 30 divided by 19. That doesn't reduce, and it's not the same thing as 41 divided by 30, so this one is no. If you check what is the pattern here, you are adding 11 every time, so this would be an arithmetic sequence. So here to determine if the sequence is arithmetic or geometric, go ahead and pause it and try to do it on your own. There is a possibility of it being neither as well. So here are your answers. The first one is arithmetic, and that's the easiest to check. So a lot of times I check that first, find the difference between the first two, and then add that to all the other ones, and it does work to be a difference of 12. If you're checking arithmetic here, the difference between the first two is 3. If I add 3 again, it's not 9, so I know it's not arithmetic. And then if I go to check geometric, I do 5 divided by 2. And then the next one would be 9 divided by 5. They're not equivalent to each other, so it's not geometric either. So in this one, it's neither. And this one, it gets from -12 divided by 6 is -2. 24 divided by -12 is -2. negative 48 divided by 24 is negative 2. So in this one it is geometric and the common ratio is negative 2. One thing to notice here, when the common ratio is a negative, what happens is that it is alternating from positive to negative to positive to negative. Where if you remember in the one where the common difference was negative, what happened was that it was becoming a smaller and smaller number, or more negative and more negative, with the arithmetic sequence. One thing I want you to understand and to recognize is when you have an arithmetic sequence, what happens when it is graphed. And basically all it is plotting points. And so the first point, the x is 1, and the term is the y value. So you have the first term is negative 8, so I have the point 1, negative 8. The second term is negative 6, so it's the point 2, negative 6, where the x value is the term number in the sequence and the y value is what that term number is. So then I would have 3, negative 4. So what I want you to see is when we graph that, this is going to be 1, negative 8, and I have these 3 points. And I want you to notice, so an arithmetic sequence turns into what type of function? If you notice, it's going to be a straight line. And so the next, say, 4 points, you would get then negative 2. You should notice that what's happening every time is I'm adding a positive 2. Also note